your grades over the weekend, you would have seen that if you were here on Friday, I stayed afterwards and I put the grades in so you can at least see what you got. I need a pencil. So obviously I have those graded. When I'm able to give those back to you, that's another story. At the end of this class, I should have all my makeups already taken care of, so that's not something that we should have to worry about. I just need two other things that I need to check on. One is to make sure that all the other teachers are okay with me passing it back. And then the other thing would be to see where it fits most seamlessly into our schedule for the week, which for me right now, I would say Thursday, but Thursday I had the lab planned, so that might push it back to Friday. I gotta take a closer look at the schedule. So I want to do it this week, but it'll either be Wednesday, Thursday, or Friday is when I'll give you the test back and we'll have a chance to go over it. Anybody that got less than a 70, your name was put on a list. That doesn't mean necessarily that you're going to qualify for it, but your name was put on a list. Once the academic intervention, the teachers running that, figure out how much space they have, they'll figure out where the cutoff is going to be. I doubt it'll be 70. It'll probably be around 65. But they'll figure out where the cutoff is, and then anybody that got less than that cutoff score would get a pass to go for the next 2 weeks to academic intervention. At the end of which you'll be able to retest. When you retest, they add up the score you got with me to the score you got with them. So they add that together and divide by 2 with a cap of 70. You can't get more than a 70. So you got a 50 the first time around, and you take it again and you get 100, a perfect score. What's 50 plus 100? 150. But then you divide by 2, that gives you 75. But since it's capped at 70, your grade, it wouldn't be a 50. Right now you'd have a 50 if that were the case, but it'd be a 70.
So the best you can do is barely pass. So the best you can do is barely pass.
Well, no, the best you can do is have it done better the first time around. But yes, the best that you can do in academic intervention is to get a 70, which you describe as being barely passing. Also in the grade book, Friday's assignment from Khan Academy, I put that in. So basically the grade book is up to date. When's your next quiz? Let's see who actually looks at the calendar. Yeah, Blake? Nah, close.
Next Wednesday.
Next Wednesday, yeah. Next Wednesday is the next quiz. It's on equations, which we'll start now. And then when's the next test? Blake? Close again.
Thursday.
Yeah, Thursday the 20th. So no assessments this week. Quiz next week. Quiz next week, test the week after. Okay. Okie dokie, artichokes. Hi, Luna. Hey. How was your long weekend?
I watched 17 videos.
Oh,
Same.
I thought you were gonna say you watched like 17 episodes of Stranger Things.
Stranger Things is a good show. It's a great show.
We filmed in my old school.
Oh, that's.
Yeah, all of it. No, it's not.
Oh, wait, no, it wasn't.
And like all of it's filmed in Atlanta.
All right, so let's give you this introduction we've all been seeking. This next unit, which you will test on 2 weeks from Thursday, deals with equations. That's what you're being introduced to. Up to now, the math problems, the questions that you've been getting have been expressions. Yes, Nishan? So up to now, we've been working with expressions. So more specifically,
We actually get to solve.
what? If only this could have been handled before class started instead of. Yeah, but I mean, for all the kids that say that I'm mean and stuff, I wonder like the other teachers would do just to get up in the middle of their class and walk and get a pencil. I wonder what they would say. Yeah, I know, but I'm the mean one though. It's okay. You got the pencil now?
Yes.
We're all set. So now back to what I was saying. We've been working with expressions, but more specifically, what have we been doing to expressions? Simplifying. Good. Simplify means to do operations. Anytime you add, subtract, multiply, and divide, you are simplifying. We did that with polynomials. We did that with radicals. Okay, we even did it a little bit with exponents. But now with equations, see, because this word gets overused, but to the lay person that is not in a math setting every day, they just think of a problem and oh yeah, that equation, that equation, that equation, that equation, and we love to use the word, but we don't really know what it means. Okay, so now is the first time we will be dealing with equations, and then specifically we will be doing is solving them. But before we get to solving them, let's talk about what the differences are. What's the difference between an expression and an equation? They both start with the letter E. They both can contain numbers. They both can contain variables. They both can contain operations. So, geez, there's a lot that's similar, but there's one thing that's different. Yes, Jonathan.
The equations have equals.
Yeah, more specifically, an equation is two equivalent expressions. What that equal sign does is it's a comparative symbol, and what you're saying is that two separate expressions are indeed the same. They're worth the same. When an expression is equal to another expression, that becomes an equation. And due to this equivalency, I can leverage the fact now that I have some extra information. I have something to compare each side to. I can leverage that in the fact that now I can do whatever I want as long as I do it to both sides. I can add whatever I want, subtract whatever I want, multiply whatever I want, divide whatever I want, as long as I do it to both sides, because both sides are they're the same. Both sides are the same. So, now we talked about what expressions and equations both have in common, and one of the things that we said was they can have variables. Today is not the first time you see a variable, but what we'll be able to do for the first time is we'll be able to solve for the variable. What is a variable?
It's an unknown number.
It's an unknown number. So like, when you have a mystery, you have, a crime that was committed by an unknown person. And then when you solve the mystery, now that unknown person becomes known. Well, it's the same thing with numbers. When we solve an equation at the beginning, we have an unknown number that by the end becomes known. You didn't have that ability with an expression. But now with an equation, we can. Now, this is something you'll hear me say throughout the year. Okay, if I ask you to pair, and there's no math involved, this is just purely paying attention. Okay, this process of solving. Okay, how do we solve? As concise as possible, using as few words as possible to describe the process. When you solve for a variable, what you're doing is isolating it. How many sides does an equation have? Two. By the time you're done, one of those two sides should just have the variable there, nothing else. Then whatever's on the other side, that's what the variable is. Two sides. Okay. So some things to consider. So now instead of doing operations, we're going to look to cancel operations because that's how we isolate. This variable is going to be surrounded by these unpleasant things that, stop bothering me, leave me alone, and it wants to get rid of them. So the way we're going to get rid of those numbers and operations is by doing the opposite operation. Opposite of adding and subtracting, opposite of multiplying and dividing. What's the opposite of exponents?
Square root.
First person today to say that correctly. Very good. Radicals. You won't have to do too much of that in Algebra There's not too many radicals, but mostly know the difference. Adding and subtracting are inverses. Multiplying and dividing. And then the last thing, please don't get this confused here. I'm not saying that a variable cannot be equal to a negative number. That's not what I'm saying. What I'm saying is that in order to be isolated, in order to be completely isolated, the variable can be the only thing on one of those sides, including negatives. There cannot be a negative sign on the same side of the variable. Saying a negative x is not the same thing as saying x. Guys, so now today you're kind of lucky, but tomorrow you're not going to be all that lucky.
Sorry, Father.
That's fine.
Ivan gets all this?
Ivan.
Sorry.
It's fine. So, see, the good news today is that your introduction is going to consist of one-step equations. Every single problem that we do today in class will consist of one step. In order to isolate, it will take you one step, having done one operation, so you don't have to consider too much of an order. When you start having to perform multiple operations, well, now you got to figure out which one do I do first, which one do I do second. So this last part of the first slide doesn't necessarily pertain to today, but it's things that you got to start thinking of heading into tomorrow. So we might as well give them to you now. Okay, how do we isolate a variable? What the textbooks will tell you is, well, now since we're not doing operations necessarily, our goal, like, yes, we're going to have to do operations, but our goal, the reasoning behind it, is because we want to cancel operations. So you should have learned something known as order of operations. What's order of operations? PEMDAS, please excuse my dear Aunt Sally. Well, now instead of PEMDAS, when you're looking to cancel operations, SADMED.
What does that stand?
I'll write it out.
No, I'm not.
No.
And really, look. See, the good thing about thinking of it this way is that it's sound. The logic is sound. If you perform that correctly, you will do the correct, you will perform the operations in the correct order. You will cancel the operations out when they're supposed to be canceled out. The problem is that if you only learn it this way, it's very easy to get confused, especially once it starts getting to parentheses. Okay? What this is telling you is, yeah, get rid of adding and subtracting first. Get rid of multiplying and dividing next. Get rid of exponents after that, and then get rid of any parentheses. But sometimes in equations, there's these hidden parentheses that are there, but you don't really see them. Yeah, when you're working with fractions, there's other, when you're dealing sometimes with radicals, there's parentheses that are there, but that you don't see, so that's when it gets kind of tricky, right? So a less formal approach to this, you will not find this in textbooks, and I'm sure that there's flaws in delivering it this way, but it's just kind of the more you solve, the more you solve, the more you solve, the more you solve, you kind of get the feeling that you're working outside in. You're going to cancel the numbers that are further away first, working your way in closer to the, what do we do? Oh, say that again, please. It's taking so long today for me to, somebody said it. To the variable. It was a girl's voice, so it wasn't each other. We were just working on your falsetto. It's a variable. Any questions there? Just out of curiosity, how many of you already have this in your notebook? Before you spent a long weekend writing the notes, so you mean?
We had 10 people.
Yeah, I'll bet. Me too. That's funny. I had at one of our not the department meetings, but like one of the subject area meetings, there was some concern expressed over whether or not I should be posting the notes ahead of time, because some other teachers were worried that too many kids would go and write the notes beforehand and then not pay attention in class. Yeah, I studied. I tried not to laugh, but that was kind of funny. All right, so here we go. Let's start the examples. So here's our first equation of the year. You might find it to be boring, but I don't want to show you just how to do this. I want to explain to you what you're doing, and maybe even more importantly, why you're doing it. Because that's what a lot of you guys don't understand. Okay? Here I have a statement of equality. Okay? If I were to read this using English words, instead of just numbers and letters and symbols, this would state that some unknown number, some number that I presently do not know, minus 28 is the same as 49. So before you get carried away, yeah, but I already know how to do this. Yeah, it's only one step. Yeah, I guess that you have done. But let's do the building blocks here. Let's build a foundation. Let's make sure we understand why. What am I trying to accomplish? When I solve an equation, what am I trying to accomplish? That is
missing.
no, one word. I'm not saying you're wrong. I'm not saying you're wrong. There's one word I'm looking for you to say over, Carmela. I want to isolate. I want X to be by itself. But then this negative 28 is like, oh, but I want to be your friend. Please be my friend, please. And the X says no. So think of this as being a wall. The equal sign is a wall. It's what breaks up the equation into two equivalent expressions. And by the time I'm done, whatever side of the wall the X is on, that better be the only thing there. So what am I trying to cancel here? Okay, so how would I cancel out a minus 28? Good, adding 28. Here's another issue that I have. And it isn't so much about in practice and what's right and what's wrong. It's do you understand the why? Do you understand the underlying reason why we do this, right? I want to cancel a negative 28. I'm going to add 28, but the whole basis behind an equation is that I can do whatever I want as long as I do it to both sides. So too many kids will say, oh yeah, 49 plus 28, and that's 77, and whoo, I'm done. But why? The reason why is because whether you realize it or not, you added 28 to both sides. The reason why you were allowed to add it to both sides is because both sides were the same. I did the same thing. I have a little balance scale that has grains of sand, and I added 28 ounces to both sides so that it would still remain level, horizontal. What is negative 28 plus 28? Zero. Yeah, it cancels out. So yes, am I performing any calculations on the left side? No. I'm canceling out just using, it's called the additive identity there. It gives me zero. Then yes, on the other side, what's 49 plus 28? Oh, mister, I got the same answer. I got it so much faster. Yeah, maybe, but maybe you didn't understand why you got it. And when these get a lot longer, you're going to struggle. Why? Like you don't understand why?
No.
Any questions here? Okay. So then here's another one. Who's being clingy now to the Y? Yeah, the 21. And so how am I going to cancel out the 21? Good, minus 21 on both sides. Both sides. On the left side, all that happens is the 21 cancels. The Y drops as if it was hot, and on the left side, negative 18 minus 21 is negative 39. Any questions there? No. Oh, another thing to be aware of, this works on any equation, whether we're doing one-step equation, whether we're doing rational equations later on in the year, which are probably the hardest types of equations to solve for an Algebra I kid. Anytime you get a solution, you should always be able to substitute it back into the original equation and still maintain that equality. still be able to have 2 equal sides. So like watch, what is 18 plus negative 39? What is 21 plus negative 39? It is still negative 18. And now, yay, we get our calculators back. Yay. You can always, if you have the time, you can always go back and check. Okay? Let's keep on going. One-step equation. Clear? I want to get the x by itself. What number do I need to get rid of? Good. How am I going to do that? Yeah. Another thing I want you to Wait, but no, don't say that. She said add it to 25. I want to hear add it to both sides. Both sides. In practice, yes, your solution is going to just be 25 plus 150. But you have to understand fundamentally that in anytime you do anything to an equation, whether you're writing it or not, whether you're realizing it or not, you're doing it to both sides. So anyways, I was going to say the other thing that you should realize, notice how on all these first examples, what we've been trying to do is cancel out an entire term. Let's go back to this original equation, right? On the side where the x was at, how many terms are there?
3.
Not in the entire equation. 2. One was a negative 150. The other one was an x. So there was 2 terms. I wanted to get rid of the negative 150, which was its own entire term. When I want to cancel out an entire term, whether it has, look, starting tomorrow, we're going to start seeing equations that now have variables on both sides. So we're going to have to cancel out even terms that have variables on them. But what I want you to start understanding is if you're going to get rid of an entire term, we do so by adding or subtracting. If you have to cancel out a term in its entirety, you do the opposite, add or subtract. Later on, when we want to cancel out just a little part of a term, a little piece, then that's when we multiply and divide. No questions here?
No.
Ooh. Luna. What do you want to pick here?
Distribute first.
Thanks, Luna.
Jay?
Yes.
You put multiply, add 65 to 15 because we're doing the same to the other side.
No.
Do we distribute the negative 1 with the negative 6?
Why does everybody say like distribute? We're not distribute means when you're doing something more than once. That's what the whole point of distributing is. That like if I were to give you a sheet of paper, I wouldn't say I'm distributing the sheet of paper to you because I'm only giving it to one person. When I distribute something, I'm
Multiply.
well, no, you actually are multiplying. I'm not sure you know what you're multiplying on. Mackenzie? Okay, so here, watch. Before I get to, but that's what I was saying. Yes. The double negative does become a positive. And what you may not realize, it actually does occur because of multiplication. Not distribution. I'm not distributing anything, but I actually am multiplying because what's technically outside of the parentheses?
A 1. A negative 1.
A negative 1. And what's negative 1 times negative 65? Yeah, positive. Why does that happen today? That gets on. What am I doing? It's like weird.
It's a nice color. I hate this stuff.
Huh. The second time.
It's a nice color.
Yeah. So okay, now Jay, now that I have a plus 65, what's the opposite? Now we subtract that. And just like before, if you wanted to, You could substitute the negative 50. Negative 50 minus negative 65 does give you 15. If you've been dying to stretch out your calculator's legs and give it a good little workout, you can put that in your calculator. You'll see negative 50 minus negative 65 gives you 15. How you doing back there, RJ? One thumbs up or double thumbs up? Cool. That's my regular reaction to when I see fractions. That was just my inner dialogue becoming my outer dialogue.
No, it sounds
Thanks,
familiar.
You really are to go.
Sounds like they know.
Okay.
No matter how scared you are of fractions, if I ask you what to do, every single one of you should know what to do. You may not know how to do it, but if I say like, hey Mike, what do I want to do first?
You want to make them have equal or the same denominator.
Nope, not yet. I'm not saying you're wrong, but that's not what I'm going for. That's not first. Go ahead, Jessica. No?
No.
Tara?
Oh.
Ooh.
Subtract.
Okay. Thank you. See? So like there's some people that I asked today and they look at this and they're like a deer in headlights. But if I ask you what to do, see, Tara, how much math was there involved in your reply? None. None. Just paying attention. Now, yes, once she tells me, okay, subtract 3 over 4 from both sides, yeah, now you have to know what negative 1 over 8 minus 2 over 4 is. That's a little bit different. But you should at least know what to do. Now we'll get into how to do it. Yes, Nate?
I was gonna.
Okay, well, what I did is I like to add an extra step here and just rewrite it horizontally. Not that you have to, but it's easier on my eyes. So that, okay, in order to subtract fractions, what needs to be true, Nate?
You have to have common denominator.
Okay, and what's the least common denominator of 8 and 4?
8.
It is 8. Weird here. So I would write G is equal to negative something over 8 minus something over 8. Because he told me that the least common denominator is 8. So now let's see. This first fraction, negative 1 over 8, is going to turn into this first fraction. And if the 8 stayed the same, that means the 1 is also allowed to stay the same. Then when we go to the second fraction, how did the 4 turn into the 8? Times 2. So watch this, the magic of technology. Viola.
Wow.
Whatever you do to the bottom, you do to the top. What is 3 times 2?
Viola.
Mm-hmm.
Violin.
Oh, you're right. Sounds better in French. Negative 1 minus 6 is? All the children rejoice because they got negative 7 over 8. What?
You want to special limits?
Well, can't we just put that on the calculator? I mean, yeah, my days of forcing kids to show all the steps with fractions and stuff, those are gone. It's just not worth the fight anymore, to be quite honest with you. And there's a chance that you could, this is my first year in Georgia, right? So there's a chance you could get away with it because if indeed, when you guys take the EOCs at the end, if you are able to use a 2-line display calculator like the one that was you were told to get, yeah, these are much more powerful when it comes to all scientific calculators will add, subtract, multiply, and divide fractions for you. It's a lot easier to key it in on these because where you have the blinker and you can just kind of type it as you see it. In the state that I was from, I don't see any of you that have it, but they when
Florida.
it's from the state of Miami, they made us use these. have a one-line display, yeah, you could still put fractions in here, but a lot of kids don't know how to do it because it's a little more technical. So, I mean, well, look, I would hope that you know how to do the steps for fractions, but as far as what I can do to force you, no, I'm kind of limited. Yeah, well, no, that monstrosity you can't use on the. That yes, usually when you see an Algebra 1 kid that has a graphic calculator, those are usually hand-me-downs. Yes. Is that a hand-me-down also?
Yeah.
All right, so look, I have one more here on fractions, but I want to make sure I get to all the operations. So worst case, you can just write this down from online. We've covered adding and subtracting. Let's get to multiplying and dividing.
Wow.
Do you know that wow spelled backwards is wow?
Wow.
Wow.
Wait.
Did you know that wow spelled backwards, spelled upside down?
Do you know what that's called?
Wow. You know wow.
When you have a word that's spelled.
Oh, I know what it's
called,
It does begin with a P, yes.
Wait, it starts with a what?
A P.
P? I remember. No, I heard it.
I knew it.
It's called a palindrome.
Oh, yeah. I was gonna say.
Race car.
I know that I heard it.
Somebody tried to in the fourth grade and I forgot the name.
Oh, that's like
Yes. Oh, stretching? Scratching? Oh, you know what to do? Okay. Okay, very good. So, as Madison just said, if you know how to read the equation, this is 3 times a number gives you 12. And if you are intent on doing the opposite of multiplying is dividing. So that's the first thing we have to eliminate is the desire to want to subtract. Because I still get some kids that, oh, -3. No, not -3, because I'm not adding the 3, I'm multiplying. But now, the other thing you have to overcome is because you're so used to this concept of switching signs, that I get kids that want to not divide by 3, but want to divide by -3.
No.
And that's not going to fly either. So, I don't know if this helps you, but the best way I could explain this, right? And I've spent all this extra wasted time trying to not just teach you how to do it or what to do, but why we're doing it. If we go back and look at, like, let's say any of these, right? I showed you that whatever we do to both sides. But understand, like here, look, what did I do to both sides here?
You added.
I added, right? So whether I'm adding or subtracting, that process of isolating involves turning the number that's on the same side of the variable into what? What is -150 plus 150? Zero. Okay? And the reason why is because 0 is what is referred to as the additive identity. You can add 0 to any number and it keeps its identity. Okay? What is anything plus 0? The same number. What's anything minus 0? So when it comes to adding and subtracting, I want to turn that into a 0 because 0 allows a number to keep its identity. But when it comes to multiplying and dividing, let's tell me this thing close again. Of course it is. Every single period today, this thing is. It's not as bad as the other one, but it's still pretty bad. I think it's me. I'm too fast.
Viola.
Hey, I saw it. That's all right.
All right, so when it comes time to multiply or divide, what is any number divided by itself? 1. Why do I want 1? Because 1 is the multiplicative identity. I want to just end up with an x. I don't want to end up with anything else on one side. I want to end up, so I want x to be able to keep its identity. So by taking this 3 that's in front, and in reality turning it into a 1, I know that you don't see it anymore, but there is a 1 now in front. What is 1 times anything? Itself. Itself.
It's identity.
So if you can't remember, wait, when I divide, do I divide by the other sign? Remember, like you want the variable to be able to keep its identity. So if you're multiplying, it's by 1. If you're adding and subtracting, it's 0. Here's another one. Caleb, what do you want to do here? Even if you know 0 math at all, as long as you've been paying attention today, at the very least, you can give me the one common thing that we've been trying to do on every single one of these equations. All right, before you give me the exact answer, let's at least answer the question I posed to him. Where even if he's having trouble with the math, as long as he's been paying attention to every single example, what one common theme has every single problem that we've done today had? We're trying to isolate. Thank you very much. We're trying, so at the very least, you could have answered that. Say, Mr. Romero, see, I really want to isolate the M. The M has all my attention. I want it to be by itself, but I really don't know how to do it. At least that would show me some type of progress. Okay, now, Deshaun, I'll let you finish it off for him. He said plus 6, but it's not going to be plus 6. Because this is when I say negative 6m, that's negative 6 times m. So I would divide by, not by positive 6, divide by negative 6. 42 divided by negative 6. It is negative 7. That's a good explosion or a good explosion? I some number divided by 7 is equal to 13. Go ahead, Jessica. Okay, how? Thank you. Multiply 7 on both sides. Listen, I realize, look, but it's so silly, but why? Nothing's happening over there. It's so boring. I need stimulation. Just get used to it. Get used to whatever you do it to both sides. Yes, on the left side, the 7 just cancel. What is 7 divided by 7? Just 1. Yeah, they cancel. And then on the right side, we get 91. Lovely. What you want to do? Negative what? Good, yes, I want to get the f by itself. Right now, pesky little negative 12 is like, please hang out with me, please hang out with me, I want to be your friend. And the f says, no, I don't want to be your friend. So instead, we just multiply by negative 12. The 3 is much more understanding and is willing to form a bond with the negative 12 by multiplying.
On the downside, he becomes negative.
Yeah, but hey, sometimes your friends drag you down, but hey, that's what friends are for.
You don't have to.
You have Mr. Romero, that's better than friends. And Isaac too. I have Isaac as well.
And me.
Deshaun? All right, this is a super duper special type of equation. Later on in the unit, you will learn that this has even a special name. When you make one fraction equal to another fraction, anybody know what that's called? What's the type of equation? It starts with pro and ends with portion. Proportion, good, yes, very good. So, Once we do specifically work on proportions, you will learn that there is a way to specifically solve these, right? There's a special procedure. Question or answer?
Oh, answer.
Okay. There's a special way of solving these, but we're gonna hold off and we're gonna abstain from that, and we're gonna just do our regular one step that we've been doing. I want to get to the x. It's being divided by 30. What's the opposite? Multiply by 30, right? Well, something else special happens here. The multiplying by 30 on the left cancels, but on the right, I had that pesky little fraction waiting for me. So somebody this morning suggested, well, hey, write the 30 over 1. You don't have to, but that's fine. And if you want to multiply first, 7 times 30 and 10 times 1, and then divide, you can. I like to show off, though. What's the biggest number I can divide 10 and 30 by? 10. So I like to reduce first. 10 divided by 10 is 1. 30 divided by 10 is 3. 3 times 7 is 20.
If you were to change the 7 over 10 into 21 over 30, would you still end up getting the same answer?
7 over 10 is not the same as 21 over 30. Oh, actually, 7 over 10, yes, it is the same as 21 over 30. But I don't know why you want to do that, though.
I know, I just thought, that before, we saw it, that's what I thought we had to do.
Yeah.
So I was wondering if it would still be correct.
Yeah, I mean, I don't know why you'd want to do that, but yes, that would work.
Like, as long as you get the correct answer.
That's the most important thing, right?
I didn't want to do it,
It's all about the destination, not the journey. I can maybe look if you quiet down, I can get further with you than I have with any other class today. Yeah. This is one of my favorite. We have these. Be able to gauge who's paying attention. This is not my. There is one that's a lot more my favorite, but this is up there. When it comes to not how. I'm not gonna ask you how to do it. I'm gonna ask you what to do. And everybody should always know what to do here. So, all right. I see that I'm multiplying an x by 2/3. So you would say, okay, well, hey, what's the opposite? Divide. But the problem is that fractions can't be divided. So we learn an alternative. Multiply by the reciprocal. So that's actually what we're going to learn is to multiply both sides. Well, wait, I don't get it. We're already multiplying. Yeah, but not by multiplying by the reciprocal, it's the same as dividing. If you want to multiply 18 times 3 and then divide by 2, you can. If you want to write that 1 under the 18, you can. That's what I did. 18 and 2 can be both divided by 2. So when I finish, I get 27.
I thought you said money 7.
Money 7?
Yes.
Here, let's be bold and go further than any other class today.
Dun, dun, dun.
What's different here?
Mixed
numbers. So the only difference between this one and the last one is that our first step should be to convert these to improper fracciones. We get negative 27 over 8, and we get 9 over 5. I gave you that little mini lesson at the beginning of the year, the review lesson on fractions. That was online. And for the second time in a row, how do we cancel out multiplying times a fraction? What's the reciprocal of negative 27 over 8?
Negative 8 over 27.
Yeah, I still need the negative because negative times negative is positive. Okay, then I'll just let you write down the rest. Once I canceled out, I ended up with negative 8 over 15.
Hey.